Welcome to our channel. Today we embark on an awe-inspiring journey into the heart of one of nature's most breathtaking yet terrifying phenomena, volcanic eruptions. Imagine the earth trembling beneath your feet, the sky ablaze with fiery debris and the air thick with ash. These explosive events have shaped and reshaped our planet, echoing through the ages. We'll untangle the science that makes them tick, revisit their mark on history, and explore their profound impact. So join us as we delve into the science, history, and impact of these explosive events that shape our planet. But what exactly causes volcanoes to erupt? You might be wondering. Well, let's dig a little deeper. Our planet, as tranquil as it may seem on the surface, is a hotbed of activity deep within. The Earth's interior is a seething, churning mass of molten rock known as magma. This magma is formed when the Earth's mantle melts, breaking down its rock into a thick, viscous fluid. Now, imagine this magma as a pot of soup on a stove. The heat from below causes the soup, or magma, to circulate. Sometimes this magma rises, pushing its way through the Earth's crust. But why does it move upwards? The answer lies in the simple principle of buoyancy. Magma tends to be less dense than the solid rock surrounding it, causing it to rise towards the surface. However, the journey of magma isn't a smooth one. The Earth's crust isn't an open highway, but a complex network of cracks and fissures. Magma, driven by the intense pressure from below, forces its way through these cracks, accumulating in magma chambers close to the surface. At this point, the magma is like a cork in a champagne bottle, under immense pressure. Any increase in this pressure, either from more magma pushing from below or the Earth's crust shifting, can trigger an eruption. The magma bursts forth from the surface, and voila, we have a volcanic eruption. But not all eruptions are created equal. Some are quiet, with magma slowly oozing out of the Earth's surface, creating what we call lava flows. Think of the gently flowing rivers of lava you see in Hawaii. These eruptions can last for months, even years, gradually building up the size of the volcano. On the other hand, some eruptions are explosive, like a shaken soda bottle, spewing ash, gas, and rocks high into the sky. These eruptions can be over in the blink of an eye, but leave behind a trail of destruction. These eruptions can vary in intensity, from gentle lava flows to explosive blasts of ash and gas. And it's this variability, this unpredictability, that makes volcanoes so fascinating yet so fearsome. Throughout history, volcanic eruptions have left their mark on civilizations around the world. This statement rings true as we delve into the past, to the times when the sky rained fire and the earth trembled beneath the might of volcanoes. Let's travel back to the year 79 AD, to the prosperous Roman city of Pompeii. A vibrant city bustling with life, Pompeii was nestled at the foot of Mount Vesuvius. One fateful day, the mountain roared into life, spewing a deadly cloud of gas, ash, and rock. Within 24 hours, the city was buried under meters of ash and pumice. The eruption claimed the lives of thousands, freezing Pompeii in time. Today, the excavated city serves as a chilling reminder of the destructive power of volcanoes. Fast forward to the year 1883, to the island of Krakatoa in Indonesia. When Krakatoa erupted, it unleashed a force so powerful that it was heard over 3,000 kilometers away. The eruption triggered tsunamis and caused global temperatures to drop, affecting weather patterns for several years. The eruption of Krakatoa is considered one of the most violent volcanic events in recorded history. In the 20th century, the eruption of Mount St. Helens in 1980 brought the reality of volcanic hazards to the doorstep of modern America. The eruption, triggered by a magnitude 5.1 earthquake, caused the largest landslide in recorded history and killed 57 people. These historical eruptions highlight the far-reaching impacts of volcanic activity. From the destruction of cities to shifts in global climate, volcanoes have the power to reshape the world in profound ways. But with each eruption, we gain invaluable knowledge. We learn about our planet's geology, about climate and ecosystems, and about our own resilience in the face of nature's fury. Indeed, while we might view volcanoes as harbingers of destruction, they also play a crucial role in shaping our planet and its diverse habitats. They are powerful agents of change, driving evolution and influencing climate. These events have reshaped landscapes and altered the course of human history. As we continue our journey into the heart of volcanic eruptions, remember this. Each eruption, each plume of smoke, each flow of lava tells a story of our planet's past, present, and future. The aftermath of a volcanic eruption can be both destructive and transformative. This sentence may sound paradoxical, but it perfectly encapsulates the complex relationship between volcanic eruptions and the environment. Let's first delve into the destructive side of the equation. When a volcano erupts, it spews out an enormous amount of matter, including lava, ash, and various gases. Lava flows, while mesmerizing to watch, are incredibly destructive. They can roll down the sides of the volcano at high speeds, engulfing everything in their path, from forests to entire communities. Then, there's the ash, a seemingly innocuous substance. But in large quantities, it can blanket landscapes, smothering vegetation and clogging waterways. It can also rise high into the atmosphere, blocking out the sun and causing temperatures to plummet, an effect known as a volcanic winter. The gases released during an eruption, particularly sulfur dioxide, can have a significant impact on the Earth's climate. They react in the atmosphere to form aerosols, tiny particles that reflect sunlight back into space, further cooling the planet. But it's not all doom and gloom. Volcanic eruptions are also a force of creation. The lava that destroys also builds, creating new land as it cools and hardens. Some of the world's most fertile soils are found in regions with active or dormant volcanoes. This is because the ash and other volcanic materials are rich in nutrients, providing a fertile ground for plant life. Volcanic eruptions can also create new habitats. The heat from an eruption can cause water to evaporate, forming clouds that later result in rainfall. This rainfall can fill the craters left by the eruption, creating lakes that serve as habitats for various species. So, while volcanic eruptions can indeed be destructive, they also contribute to the cycle of life on Earth, embodying the concept of creative destruction. Even in their fury, they lay the groundwork for new beginnings, shaping the environment in ways that are often overlooked. However, volcanic eruptions also play a crucial role in the Earth's ecosystem, enriching soil with nutrients and creating new landmasses. As we continue to study these fascinating phenomena, we gain a deeper appreciation for their role in shaping our world. Today, advances in technology allow scientists to monitor and predict volcanic activity with greater accuracy than ever before. A fascinating blend of geology, physics, and chemistry. Volcanology is a field that's rapidly evolving due to the advent of modern technology. Traditionally, volcanologists had to rely on physical indicators such as smoke, ash, and minor tremors. But now, with the help of cutting-edge tools and techniques, we can peer beneath the Earth's crust and gain insights into the inner workings of volcanoes. High-resolution satellites orbiting the Earth provide real-time imagery of volcanic regions, helping scientists track changes in landforms and thermal activity. Additionally, seismometers installed around active volcanoes monitor the frequency and intensity of earthquakes, providing valuable data on the movement of magma beneath the surface. When this data is combined with measurements of gas emissions and ground deformation, it paints a comprehensive picture of what's happening inside a volcano, often long before an eruption occurs. One of the most significant advancements in this field is the use of AI and machine learning. By feeding historical and real-time data into sophisticated algorithms, scientists can now predict volcanic eruptions with a level of accuracy previously thought impossible. This can mean the difference between life and death for those living in the shadow of a volcano. But it's not just about predicting eruptions. These modern methods also enable scientists to study the long-term trends and patterns of volcanic activity. This, in turn, contributes to our understanding of the Earth's geological history and the role volcanoes play in shaping our planet's future. It's a testament to human ingenuity that we've gone from merely observing these formidable forces of nature to actively monitoring and predicting their behavior. And while there's still much we don't know about volcanoes, we're better equipped than ever to face their challenges head-on. By studying seismic data, gas emissions, and ground deformation, Volcanologists can provide early warnings of impending eruptions, helping to save lives and mitigate the impact on communities. Indeed, the power of nature is immense, but so too is the power of knowledge and technology. As we've seen, volcanic eruptions are a powerful reminder of the Earth's dynamism and resilience. These majestic and terrifying events offer us a glimpse into the heart of our planet, revealing the potent forces that lie beneath the surface. From the molten magma that fuels their fiery displays, to the towering plumes of ash and gas that paint the sky, each eruption tells a unique story of pressure, release, and transformation. Throughout our journey, we've delved into the causes of volcanic eruptions, explored their impact on human civilization and the environment, and examined the modern techniques used to predict their occurrence. We've seen how these eruptions have not only shaped our physical landscape, but also our understanding of the Earth and its complex systems. But beyond the science and history lies a deeper lesson about our relationship with the natural world. Volcanic eruptions remind us of the Earth's inherent power and our need to respect and understand it. They underscore our vulnerability to the forces of nature and highlight the importance of preparedness and adaptability. By studying these awe-inspiring phenomena, we gain valuable insights into the inner workings of our planet. This knowledge equips us to better anticipate and respond to natural disasters, ultimately helping us build more resilient communities. By understanding and respecting the awesome power of volcanoes, we can better prepare for and adapt to the ever-changing forces of